Functions of difference quotients. We have this definition where we have a function called f of x plus h minus our function of x, all divided by h. This can be true if and only h is not equal to 0, because we cannot have 0 in the denominator. If we have 0 in the denominator, it'd be undefined, and in the graphing world, it's called a vertical line. So let's work with this example of f of x equals 2x squared minus x plus 3, and let's apply this functions and difference of quotients, which means the definitions of difference quotients of a function is this here. So what we're going to have to do is we need to find out what is x plus h, and then we're going to subtract it from the main function. So let's just do it in parts. F of x plus h. Everywhere as I see x, I will need to put in this x plus h. So when I do this, I see that this parentheses is squared. That means there's two of them being multiplied to itself. So let's just rewrite it, and I'm just going to rewrite the last part. We'll distribute the negative sign next. So working on these two parentheses, we always have to bring this 2 down. If we do not bring it down, then our answer is not going to end up yielding the correct answer. So it's very important. Let's just bring this one down. And let's use the full method. We have our first times our first, which is x times x. And anytime we multiply like bases, we add the powers. So x times x, and they both have a power of 1, that means it's going to be x squared, because 1 plus 1 is 2. And then my outers, which is x times h, and they're both positive, so it's going to be a positive xh. And now I have my inners, and they're both positive, and it's h times x, so it's a positive. And I'm just going to write xh just because that's how I wrote the other one. Guys, in multiplication, it's commutative, so we can flip it. And if you don't understand that, just a little side note, like 2 times 3 is 6. Well, 3 times 2 is 6 too. So that's just why I can flip-flop these two in multiplication. And now I'm going to multiply my last times my last, and they're both positive, and they're like bases, so that means the powers are going to be added, and they both have a power of 1, so it's going to be h squared. Okay, so let's close the parentheses. Now let's distribute this negative sign here to everything inside the parentheses. So negative times positive gives me a negative x. Negative times positive gives me a negative h. And then we're going to bring down the plus 3. One more step before I distribute that 2. Let's clean this up. We're going to combine any like terms, and I notice xh and xh are like terms. So I'm going to read the signs. Positive xh plus xh means I'm going to end up with 2xh, because we're going to add them together. And now let's bring everything else down. Alright, now let's distribute this 2 to everything inside the parentheses. So now I got 2 times x squared, 2 times 2xh, which is 4xh, 2 times a positive h squared, and then bring the rest down. And so now we're going to look to see if we have any like terms to combine, and in this case we do not have any like terms. So now that I know that what this is, I can go ahead and apply this definition. I have 2x squared plus 4xh plus 2h squared minus x minus h plus 3, and it's going to be minus the original function, the f of x function. And what is the f of x function? It is 2x squared minus x plus 3. And this is all divided by h. Okay? So now, what I'm going to do is I'm going to distribute this negative sign to everything inside here. So I got 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Negative times positive is a negative. Negative times negative is a positive. Negative times positive is a negative. All divided by h. And what I'm going to do is I'm going to go through here and mark out any like terms, and then I can reduce. So I see that at 2x squared and a 2x squared here, and this is a negative and a positive, so this one, they go to 0. xh, no other xh. h squared, no other h squared. Oh, I do have an x here to the first power, and it's a negative and a positive one, so they go to 0. I have a positive 3 and a negative 3, so they go to 0. And now I'm left with 4xh plus 2h squared minus h, all divided by h. You can rewrite it if it makes it easier for you in terms, separate terms. And then next we're going to reduce. H goes into h1's time. H goes into 2 h's and leaves me with 1 behind. So if you divide by like bases, we subtract powers, and it's always top minus bottom, 2 minus 1. And then h goes into h1 time. And now let's write our final answer. We have 4x plus 2h minus 1, and that is my final answer.